Welcome to Learning Intention 7, Introduction to Inequalities. In this video, we're going to have a look at a topic called inequalities and how we can use and represent them. Now, first consider this example. Bev sent her son Steve to the shops. Steve was instructed to purchase 12 rolls of toilet paper, 2 bottles of hand sanitizer, and a bar of soap. How many items did Steve purchase? Well, using our knowledge of equations, we can say that let x be the number of items purchased, and therefore Steve purchased 12 rolls of toilet paper. He then purchased plus 2 bottles of hand sanitizer, and finally he purchased 1 bar of soap. So in total, Steve purchased 12 plus 2 plus 1, that is x equals 15. Thus, Steve purchased 15 items. If I was to plot that on a number or number plane, I would write 15, 17, and 13 to just annotate, and then I would plot it right smack bang there. X equals 15. Now consider a different scenario. Bev sent Steve to the shops. Steve was instructed to purchase at least 12 rolls of toilet paper, 2 bottles of hand sanitizer, and a bar of soap. How many items did Steve purchase? Well, the model that we originally had, x equals 15, does that really work? Think about it. In this situation, he was asked to buy at least. So did he come home with exactly 15 items, or could he have come home with more items? Well, in this situation, this mathematical model doesn't hold up because x could be greater than 15. So how do we solve this, or how can we build models where we don't have exact values? Enter inequalities. So inequalities are a way of modeling systems where the value is not fixed. It can be greater or it can be less than a particular value. We've got these 4 operators here which replace our equal sign. So this one here is an arrow pointing to the right. That means greater than. An arrow pointing to the right with a little line underneath. That means greater than or equal to. Pointing to the left, it says less than. And pointing to the left with a bar underneath, less than or equal to. And once again, this symbol goes in place of the equal sign. So going back to our story of Bev and Steve, we could write x is greater than or equal to 12 plus 2 plus 1. Thus, x, the amount of items Steve came home with, is greater than or equal to 15. So this is actually the mathematical model that would represent this particular situation up here. Now, if we wanted to plot this on a number line, once again, I've got my real number line here. I'll simply annotate it and I'll say 15 is here, 13 is down here, and 17 is here. And to graph something on it, it's at x is greater than or equal to. So I'll draw an open circle on the number line at 15, and I'm going to draw an arrow pointing to the right. And then I'll fill this circle in because it says it touches at 15. So what this represents is x is any value at 15 or above, but not below, because x is greater than or equal to 15. So in conclusion, inequalities are a tool of expressing mathematical models of variables that are not fixed on a singular point. Or it can be said that inequalities denote the nature of imbalance between quantities. So let's have a few, or look at a few questions. over here, state whether the following inequalities are true or false. So 5 is greater than 7. Is that true? No, it's definitely not. 5 is in fact less than 7. What about 5 is less than 7? That is true. 5 is less than or equal to 7? Well, it's not equal to, but it is in fact less. So yeah, we'll say that is true. Actually, no, we'll say it's false. Oh no, true. I guess it's true. 5 is less than or equal to. What about this one here? 3 plus 5 is 8. 4 plus 4 is 8. So 3 plus 5 is greater than 4 plus 4. Is that true? No, they're actually the same. So that would be false. 8 is greater than or equal to negative 1. Well, we do in fact know that 8 is indeed greater than negative 1. Thus, it is true. Negative 1 is greater than 7. No, it is not. And finally, a is greater than or equal to a plus 1. So think about it. If a was equal to 0, would 0 be greater than or equal to 1? No, 0 would be less. What about if a was 5? 5 is greater than or equal to 5 plus 1? Again, no, it doesn't hold up. So the answer is false. Now we've had a look at how to do or how to work with these inequality operators. What about the representation? Inequalities can be expressed on the number line. So notice for x equals 15, we would simply mark, say 15, and that would be the answer. Or if x was 17, we could just mark it at 17. But what about graphing x is greater than or equal to 15? Well, we can graph this by simply marking the number on the number line, and notice how it's greater than or equal to. Because it could be equal to, we close this circle up. So it's a closed circle, and then depending on the direction this arrow is pointing, we draw an arrow on the number line in said direction. Remember to put the arrowhead on this line, otherwise it isn't a proper graph. So what this says at 15, if you can read it underneath the circle, at 15, x is equal to 15 and everything above the value of 15. Going downwards, x is greater than 15. So I'll quickly redraw this. Remarking the number line. Says x is greater than 15. So in the example up here, it says greater than or equal to, where over here it's just greater than. In the case that it's greater than, I'll draw a circle, but in this case, I won't close it up. I'll leave it unshaded. And I'll draw it as before. So why is this one open and this one is shaded? Well, the difference is, or the way I like to think about it is, in the top example, x is equal to or greater than. Because it's equal to, it touches that point on the number line, whereas down here, it's just greater than. It cannot be equal to 15. So you can see that the circle goes around the point of 15, so it doesn't actually touch, hence the reason I leave it unshaded. Now doing a few questions, let's graph a few of these equations and inequalities. So x equals 3, drawing my number line. We'll say 3 is here, and x equals 3. Bang, bang. Drawing another number line. Just as a side note, in the test that you'll be doing, you'll need to draw these with a ruler. I can't actually do it because my laptop doesn't have a ruler function on it. So I'm just going to have to freehand it. Now, x is greater than 3 here. So I'm going to mark 3, 4, and 2 on the number line. Now it says greater than, so what am I going to use to draw that? Well, I'm going to draw an open circle on 3, and it's greater than, so the arrow will point to the right, and I'll leave it unshaded. B is greater than or equal to 4 plus 5. What could that be? Well, let's just evaluate this expression on the right, and we'll say B is equal to 4 plus 5, that's 9. So putting 9, 10, and 8. I'll mark the point at 9. I'll shade it because it is equal to, and then point to the right, the direction of this symbol here. Going over, h is greater than 3 times negative 2. Evaluating, that's negative 6. So negative 6, negative 7, negative 5. So we'll draw an open circle on the negative 6, and it points to the right. Y is less than or equal to negative 1, marking the scale. Let's draw it. So an open circle, shade it because it's less than or equal to, and then it's pointing to the left. So it's going to be y is equal to all of these values to the left of negative 1 inclusive of negative 1. Now here's where it's a little bit different. A plus 1 is less than 15. Notice that there's a constant with this variable. I'm actually going to treat this as if it was an equation, and to get rid of this negative 1 over here and isolate A, or make A the subject, I'm going to take 1 from both sides of the equation. Thus A equals 14. Annotating my number line. I'm going to draw an open circle on the 14. And the arrow pointing to the left, and I'll leave this unshaded because it does not include the point 14 because A is less than 14. So that concludes all of the subject matter for Learning Intention 7.